let us start with the next question, which is question number 5. From the displacement time graph of a cyclist given in a figure 2.39, find the average velocity in the first 4 seconds, the displacement from the initial position at the end of 10 seconds, the time after which he reaches the starting point. Okay, a complex kind of graph is given to you all, which might not be discussed in the videos which I have sent. So I would like to discuss this graph first before solving the question. So let us try to understand the graph of a cyclist. So the graph has been divided into different portions, A, B, B, C, C, D, D, E, E, F, F, G, and then G, H. So graph has these various different portions. Let us discuss one by one. So we are actually whenever we are solving this kind of problems of for class 9, for all the numerical problems, here we are discussing about the object which are moving in a straight line. So not those objects which are moving in a curved path, they are just moving in a straight line. The graph might be curved, but it is for those bodies which are moving in a straight line. So let us try to understand this sum with the help of diagram. So here let us discuss portion by portion. So if I take the portion AB, suppose we take the portion AB. So here the cyclist first moves in a straight line for 1 second, the cyclist moves for straight line for 1 second, and then from B to C, and then from B to C, and then from B to C, you can see the turn in the graph, but the cyclist is not taking the turn. It's just moving little bit slower from portion B to C, which means how can I say that it is moving slower in the portion BC? Because if you compare the slopes of this portion and this portion, it has a steeper slope. So steeper slope means of a displacement time graph means the velocity is more because the slope is more. Again, if you consider the portion CD, if you consider portion CD, you see this portion of the graph is parallel to the time axis. That means this kind of graph is only for those objects which does not move, which are at rest. That means the cyclist does not move in the portion CD. It stops. Okay, and it stops for, if you can see, for if it stops for 2 seconds, that is from 3 to 5. And then from 5 seconds to 7 seconds, what does it do is, you see the graph is coming down. That means the cyclist is moving back to its original position, right? So the cyclist is moving back to the original position. And now portion EF, that means it at 7 it reaches the original position here. It started from here at 7 seconds. At the end of 7 seconds, it reaches again to the initial position. And now for portion EF, that means for portion EF here, EF, it is going back. It is going back again away from the original position, but still the cyclist is moving in a straight line. So the cyclist is going back. It reaches to -10. -10 means, suppose it reaches exactly at the opposite direction. Suppose it is moving towards east 10 meter, then it moves, -10 means towards west 10 meter. Again stays now EF. Now the portion FG, here FG, if I consider FG, what happens is it stays here for how many seconds? If I see, from 9 seconds to 12 seconds. So how many seconds? 1, 2, 3. For 3 seconds stays here at rest. And then the last portion G to H, you see the graph is moving up. That means is again coming back to the original position. That means where was the original position? If you see, this is the original position. That means the last portion GH means it's coming back to its original position. So it's quite complicated here, but I expect you to imagine all these things. So let me revise this again. So in the first portion AB, the cyclist is moving faster, and then in a straight line, and then the portion BC, the cyclist slows down but in the same direction, and the portion CD, the cyclist stops for 2 seconds, and the portion DE, the cyclist is coming back to the original position, and for portion EF, the cyclist is going in the opposite direction. That's why the graph is going to the negative part, opposite direction. And for the portion FG, the cyclist is staying there, that means not moving, for 3 seconds. And then the last portion GH, the cyclist is moving towards the origin now. So this is the explanation of the graph. Now the solution is not so hard. The solution is easy actually. I just wanted to explain the graph. So the solution, the first question, the average velocity in the first 4 seconds. So displacement is 10 meter, first 4 seconds. 1, 2, 3, 4. The displacement is 10 meter. The time is 4 seconds. Hence the velocity will be displacement by time, which is 10 meter by 4 seconds. The answer is coming up to 2.5 meter per second. Number 2, the displacement from the initial position at the end of 10 seconds. So at the end of 10 seconds, that means here, and they are asking us the displacement from the initial position. This is the initial position at the end of 10 seconds. So if you see number 2, for t equals 10 seconds, the displacement is minus 10 meter. For 10 seconds, the displacement is minus 10 meter. That means it has moved to the opposite direction. And number 3, the time after which he reaches the starting point. If you see the time after which he reaches starting point, you see the graph, starting point is this, at the end of 7 seconds, and again at 13 seconds. So there are 3 portions, A, E and H are the 3 points of the graph where it touches the origin, which is the initial position. Hence the times are 7 seconds and 13 seconds. Sorry, this is not 3, this is 13 seconds. So this is number 5.